Hey everybody, so what I wanted to do in this video is very quickly walk you through how to create graphs and plots and figures in JASP. It's pretty easy to do. I think it's way easier than a lot of the other stat software that I've tried. So let's get into it. A lot of this is stuff that we're going to be incorporating into future assignments throughout the semester. So usually whenever you're analyzing data, I'll probably ask that you attach a figure or a graph. And so here's how to do that. So this will be probably a super short video. So I'm going to open up, for example, I'm going to open up our JASP assignment 1. So this is that data set that you worked with JASP assignment 1, so you're already a little bit familiar with it. But whenever you were calculating that, you were creating tables, right? You were basically creating, looking at, the range and stuff like that of your data. But let's take a little bit of a step forward. So let's see if we can, what else we can do with JASP. All right, so again, we'll want to go to descriptives. So just in case you saw where I went there, I went to descriptives. So if you go over to descriptives, so we got our data right here. It's all nice. We're going to go to descriptives, and now we have. Whoops, I didn't mean to. Let me remove this. My bad. All right. So we're starting over. Okay. So we got descriptives, and now this, this table is ready to populate, and we have these different values. So where we are going to want to go to add figures that JASP can create is right here under plots. And so you can see there's already a pretty good amount of options that we have. So we got box plot. That's familiar, right? We talked about box plots a lot this chapter. But we also have distribution plots, so we can also look at things like histograms and things like that. That's what a distribution plot is. It doesn't, I don't know why it's not called a histogram. It's kind of annoying. But yeah, let's take this for a spin. Let's see what we can do. Let's see if we can find any interesting things. So what I'm going to do first is actually divide the data very similarly to how we did the previous assignment. So we want to look at the living distance over years. So this is what we had last time, right? But now we want to graph this out. How should we do that? Let's make a box plot. Let's see what that looks like. So you just go down here, you just click on box plot, and it automatically creates this figure for you. And so it very politely gives you the y-axis and the x-axis and all that other stuff. And the nice thing about JASP is that it usually almost always gets it right. Whenever I've seen students try to create this stuff in Microsoft Excel, oftentimes there's some confusion about the different axes, and that's a headache. But this is telling us exactly what we want to see, where we have the living distance in miles right here on the y-axis, and the years that they are: first year, sophomore, junior, senior over here. And we can see that there's pretty similar kind of distributions throughout, right? That basically, that they run big spreads. Are there any outliers? No, I don't see any outliers. I don't see any dots, right, that are on there. But if you were interested in outliers, you could always select label outliers, and that will tell you exactly what the values are that would be outliers if we had any. In our data, we don't have that, but that's okay. If you wanted to, you could play around with these different other pieces. So this is a violin plot. We didn't talk about that in the chapter, but it just kind of shows you the different kinds of densities of the distribution. A jitter plot, which is showing you the total spread of the data across here. So that's kind of fun, kind of cool. Or we can even overlay them, which is can also be very helpful to help visualize that data. All right, so that's box plots. But let's explore a little bit more. So I don't know. Let's get rid of these, and let's say I want to use a pie chart. I click pie chart, but nothing happens. What the hell? JASP is broken. I can't believe it. This class sucks. That's actually not true. This class is awesome, and JASP is pretty good. But the reason why pie charts doesn't come up is actually because the data that we're splitting is incompatible with what a pie chart should be. So JASP is preventing us from presenting the data incorrectly. Good job, JASP. Good job. So how do we get around this? Well, it just means that we're conceptualizing the data in the wrong way. So, okay, so let's start over. So I'm going to move this over. And now, remember, we want to look at nominal data, really. We want to look at qualitative data when we are looking at a pie chart. So, do we have any of that here? Yeah, we do actually. We have, year is a nominal data, right? Or it can be. So we're going to put that in the variable, and boom, there it is. So we see that there is, a very rudimentary a pie chart that is reflecting the different proportions of people allocated throughout the year. This is a little bit confusing because the way that they have this divided up, it has these numbers from 0 to 20 to 40, 60, and 80. Basically, it's just showing you where the 20% part of this pie would be. That's kind of confusing though. So you can kind of ignore that if you want to. But it shows you, okay, it looks like in our data that the smallest group is going to be the third years. So not very many juniors compared to the others. But for the most part, they're pretty well equally distributed in our pie chart. So that's helpful. You can't find, you can't really find data distribution the same way you can with box plots. You can't find outliers in pie charts, but in case you wanted it, it's there. We can also look at a distribution plot, but this is where you got to be kind of careful, is that this distribution plot is basically a histogram, or it could be a bar chart. It really depends, and that's why it's called a distribution plot, is because JASP doesn't quite know if your x-axis here is quantitative or qualitative. So for us, it's qualitative, right? That you're either a first year, a second year, a third year, or a fourth year, according to our data. There's not the case where people that are between these two count, right? We're lumping them all into these four categories. And so that's what we're looking at here. So this is not a histogram. We'll look at a histogram in just a moment, though. I think. So here what we're looking at is, okay, yeah, this confirms what the pie chart was showing us. There are fewer people in the junior setting here. So you can kind of play around with that if you like. But all right, let's get rid of years. Let's try some other fun stuff. What do we have? Let's try living distance is going to be our variable. Now this is good stuff. So this actually is a histogram. It's the same distribution plot, but this is a histogram. Why? Because now we have living distance, and living distance is a ratio scale variable. But you can see that JASP has grouped it up into bins. So we have from 0 to 10, from 10 to 20, 20 to 30, 30 to 40, and so on. And we can see the distribution of this data now, right? So this doesn't really follow a normal distribution, right? It doesn't follow... it's not really positive skewed or negative skewed. It's just it's kind of flat, right? So that's helpful to know whenever we're looking at this, but not super surprising. Not super surprising given what we've seen in this data so far. But we can see that probably most people live between 0 and 10 miles, or from 60 to 70 miles. There must be kind of a city, 60 to 70 miles away. So, that gives us a little bit of an indication here. If we want to, we can click Display Density, and that gives us a nice frequency polygon over it. This one kind of smooths over the edges, so it's not as jagged as the frequency polygons that we saw in the chapter and in the textbook, but you get the idea. And that's pretty much it. So, that shows you kind of what you might be interested in. We can try some other things like scatter plots. Let's see what we can do with that, if we can get any of these to work. So I'm trying to split this up by year and by living distance. And you see, it doesn't tell us what that scatter plot is, which tells us, oh, this data is not appropriate for that. So let's see if we can find something that would be appropriate for that. I'm going to put in living distance and satisfaction with commute. Oh, and that's super complicated. I'm going to take out some of these, some of this right here. Okay, so this is still kind of hard to understand, kind of hard to read, but what we're looking at right here is on the y-axis we have the satisfaction with the commute, and on the x-axis we have the living distance. And you can see there's not really any kind of systematic trend that I see here. I do see that there are these different lines, but remember that we do have a problem with the scale here. The scale only goes from 1, 2, 3, 4, and 5. You can't have a 4.5, you can't have a 3.5, and that's why it's in these lines. But even still, I don't really notice too much of a trend here when we're looking at this. But you would use this if you were looking for correlations and things like that. We haven't really talked about that too much in this chapter. We won't talk about it actually until towards the end of the year, but that gives you an idea. So think of this section down here, the plots, that these are supplements that you can use to help flesh out what you're trying to tell your audience. So you've calculated your stats, and now you're helping show them what your stats are saying. All right, so I think that's pretty much it. So feel free to play around with these different plots. They can be kind of fun to play around with. If you you can try using labels for colorblind folks, just to mix things up a little bit. All right, so if you have any questions while you're working on this, let me know. Otherwise, you can expect in your JASP activity number 2 to be tackling how to plot your own data on your own independently. All right, so I'll see you there. I'll see you later. Bye.